Hi, and welcome to Failurology, a podcast about engineering failures. I'm your host, Nicole.
And I'm Brian, and we're both from Calgary, Alberta, Canada.
Happy New Year! It's 2023. I can't believe it, but it's 2023 already.
We're off taking in some much needed R&R time, which is rest and relaxation.
Yes, we like to take this time during the holiday season to spend it alone in our respective living rooms on our couches because we are both introverts and we need to recharge.
It is great. I highly recommend it to everyone.
Along with rest and relaxation, I, for one, am also likely making goals for 2023. In fact, we're recording this prior to the new year, and I've already started making my goal list. So I'll finalize that at the beginning of the year. I like to look forward to all the different things that I'm hoping to accomplish. And I like to make lists and cross things off. So I find that really helpful for my productivity. Not that it necessarily needs help, I wear a lot of hats.
However, we didn't want to leave you hanging, so today we are bringing you one of our mini failures. This one is mini failure 22 about the Johnstown Flood or the Great Flood of 1889. This was caused by the collapse of the South Fork Dam upstream of Johnstown, Pennsylvania.
And if you enjoy this mini failure in a more condensed, lighter version format, please check out our Patreon page. We have, at this point, well over 30 mini failures that we've done. They have pretty straightforward causes, or there's not a lot of info because they happened a long time ago. And so they're shorter episodes. There's no news, no ads, and they're a lot of fun to put together. If you're interested but not quite sure, check out our website, failurology.ca. On the exclusive content page, there's a list of all the mini failures that we have done to date. And that only costs $5 Canadian a month, which is like pennies in other currencies. Before we get into the failure, we do have some engineering news for you. This one is about the Exchange Tower in Detroit, Michigan.
You may have heard about it. I just learned about it a few weeks ago, or I guess a couple months ago when this episode comes out. It is a building that they are building from the top down, which I thought was wild because most buildings get built from the ground floor up. This one is really from the top floor down. So the Exchange Tower is 207 feet tall, 63 meters, and it's a 16-story residential tower using the LIFTbuild technology construction method. Essentially, how this works is they build all the floors on the ground and then they hoist them up to their final place in the tower. So the building starts where they build the core, or the spine as they're calling it, which is two concrete structures in the middle of the floor plate that hold the elevator and the staircases. Then each floor is constructed on the ground and hoisted up into place, whatever floor it's supposed to be, around the spine. So this construction method was chosen as a way to eliminate fall hazards and inefficiencies, and they are intended to reduce costs by 10 to 20% and the schedule by about 30%, which is a tall order, and I find it just really, really cool. So the lifts themselves in this building, it takes about 7 hours per floor to lift them into place, and then another 4 hours to kind of lock everything in around that spine or the elevator core.
I agree. This is a pretty cool construction method, something I haven't quite seen before, at least not done this way. There's similar applications being used where buildings are prefabricated off-site before being installed with the rest of the building. But in this method, that prefabrication happens on the ground. So they're kind of have a building factory at the ground level, and then they raise the floor up to its final place on the tower. That said, this building in Detroit has the same offset windows as a building we have in Calgary called the Hub, which is near the University of Calgary. And I very strongly dislike that building.
Me too. It is on top of a hill. Everything else around it is fairly low. This building is like a 20-story building, Nicole, 24-story building. So you can see it from a long way away.
I think we've mentioned it before. We've definitely talked about this, if not on the podcast, definitely at the pub, because I don't like this building and I will talk about it for a long time. So for a variety of reasons, some of which are logistical and some of which are aesthetic, the windows don't line up and they offset on each floor, and they seem to offset kind of randomly. But when you look at it, it looks like they have, the building itself is white and the windows are a dark color. So it should be vertical lines, is these jagged offsets throughout the tower. And while I get how we may have arrived here, I don't want to look at it. I just don't want to look at it ever again. I don't like the building. I very strongly dislike it. And I just want the windows to line up. It's a problem. It's a problem. And you can see the building, like Brian said, you can see it from so many different vantage points in the city because there's no other buildings around it. And maybe that's the solution. Maybe that building stays, because obviously they're not going to tear it down. That's ridiculous. It's brand new. But let's build a bunch of buildings around it so no one else has to look at it. Please. Please. So I don't know if this building, the Exchange Tower in Detroit, is the same architect, but even a few floors in, you can already start to see the window offsets, and I just can't. But if you want to read more about the Exchange Tower in Detroit or this LIFTbuild method, the link to the article can be found on the webpage for this episode at failurology.ca.
Without further delay, here is our mini failure episode that is now this regular episode on the Johnstown Flood. The new season of the 32-team professional hockey league that plays in Canada and the United States has started, which means the Toronto professional hockey team might win the end-of-season mug.
When hell finally freezes over and the Toronto professional hockey team wins the big game, there's definitely going to be a parade.
Toronto Professional Hockey Team Parade Planning Services is your one-stop sports mug championship parade planning service.
Don't be like Vancouver. They rioted because their professional hockey team has never won a championship.
Call Toronto Professional Hockey Team Parade Planning Services toll-free at 1-866-865-1967.
Hi, and welcome to Failurology, a podcast about engineering failures. I'm your host, Nicole.
And I'm Brian, and we're both from Calgary, Alberta, Canada. Welcome to our 22nd mini failure episode.
Do you have any age jokes that you want to insert here, Brian?
I actually don't, but I did look up to see if there was anything cool with the number 22, and I found out that in 2008, a world record was set for the most people riding a skateboard, which is 22, and it was for a Weezer video. 22 people on a skateboard, I think, is pretty ridiculous.
On one skateboard?
One skateboard, not even a big skateboard, like one normal-sized skateboard at 22 people.
And were there 44 feet on the skateboard, or were they stacked? What does this look like?
I am unsure of that part. I'm gonna guess that they were stacked. I mean, you can barely fit 2 people on a skateboard. 22 people seems like a lot. So maybe it was a troupe of acrobats, the people that balance on each other, cheerleading people.
Not for me. I don't think that's for me.
Also not for me.
Anyways, we're bringing you engineering failures in bite-sized pieces.
Make no mistake, though, these are still significant failures, but they either have pretty straightforward causes or not enough information for a full episode of Failurology.
These episodes are also just the failure, no news, and no ads. For now, at least.
It's like Failurology Light.
This week's mini failure is about the Johnstown Flood, also known as the Great Flood of 1889. So this one is a long time ago. Johnstown has had a number of floods over the years. Kind of makes you wonder why they put it in such a low-lying area, but that's neither here nor there. So this flood happened on May 31st, 1889, 133 years ago, when the South Fork Dam, which was 23 kilometers upstream of Johnstown, Pennsylvania, catastrophically failed after several days of extremely heavy rainfall. Fun fact, Johnstown is about 2.5 hours west of 3 Mile Island that we covered in episode 41. As you know, I Google Map every single episode that we do, every single failure. And so, of course, when I realize that Johnstown was in Pennsylvania. I was curious. I thought it would be really cool if they were on the same river, but unfortunately that's not the case. They are on separate rivers, and it looks like they're from separate bodies of water, although I didn't quite trace the rivers back to their exact origin. But yeah, I still thought that was pretty cool. So 2.5 hours west as you drive, not necessarily as the crow flies, as they say.
Let's talk about the South Fork Dam for a little bit. The South Fork Dam was an earthenworks dam, and we've talked about these a few times on episodes before, but to recap, or if you haven't heard the previous episodes, they're essentially a mound of dirt that's meant to hold back water. So the same sort of concept that you built in sandboxes or you built as a kid, you just stack up a whole bunch of dirt and mud and it holds back the water. At least it does in theory. These are, of course, they're engineered for water forces and materials that they use in them, but to non-dam builders like myself or Nicole, they just look like hills of dirt.
That's the technical term. Hills of dirt.
Mounds of dirt. The South Fork Dam was built on the Conway River between 1838 and 1952 by the state of Pennsylvania as part of a canal system to be used as a reservoir for the state's canal basin. It was later sold to the Pennsylvania Railroad, which eventually was acquired by Amtrak and then sold again to private groups. The group that owned the dam at the time of its demise was the South Fork Club, a hunting and fishing club. The dam is 22 meters high, 284 meters long, and 3 meters wide at the crest and 67 meters wide at the base. Like we said, it's a giant mound of dirt. The outlet works included a stone-lined culvert with 5 valves for releasing varying flows. There is also a spillway on the east abutment, and the plans called for a 45-meter spillway, but the actual width installed was only 21 meters wide.
So right from the get-go, we already have problems. They've already undersized the spillway by about half. And that's going to play a factor. Not good at all.
And that's just the start of the problems with this. So after a decade of poor maintenance, the outlet culvert collapsed and a portion of the dam washed out. We're not doing very well so far. The dam had sprung a number of leaks between 1881 and its demise in 1889. Previous owner had also sold 3 of the cast iron discharge pipes from the collapsed culvert for scrap. And these pipes allowed a controlled release of water, which to me seems pretty important. Being able to control how much water and when it goes out of your dam, that's a good function to have.
Also, I want to mention, I wasn't able to confirm specifically if it was the South Fork Club that owned the dam and they were the ones that sold these cast iron pipes. I couldn't confirm that for sure, but if I'm reading between the lines, they, I think, are the most likely candidate for that. And they play a very important part, not a great part, but an important part in this story. So I did just want to mention that. That's my theory that they were the ones that sold those discharge pipes, but I wasn't able to confirm for sure.
In addition to the parts of the dam that failed, the South Fork Club also lowered the dam crest to allow carriage travel across it, adding a mesh screen on the spillway to prevent loss of fish and using brush, clay, and hay to patch the washed out segments. Not really ideal for this.
For being from 1889, there was still quite a bit of data on this failure, which I was pretty impressed with because it's a really, really old one. I will get to this. There was a formal investigation. I wasn't able to find a copy of that report, but there have been a lot of reports that have, I guess, tried to argue that initial report. And so there was quite a bit of information. I still think the failure was pretty straightforward, which is why we chose to do this for a mini failure episode. I also want to say, just, kind of recapping what Brian's just talked about, it seems like the state of Pennsylvania had this engineered dam that they built. And yes, the spillway was smaller than it should have been, but for the most part, the dam construction was on par with what it needed to be. But then they kind of just built it and forgot about it. And no one really maintained the dam. I don't think the South Fork Club understood the importance of the dam or how all of the different components worked or how critical the dam was to all the neighboring communities downstream. And that's really unfortunate because like all of the failures we talk about, this one, of course, was preventable. All dam failures are preventable, and I do find them really, really interesting. We've talked about earthen dams before, and I honestly find them fascinating. Just to call back to the Teton Dam that we covered in a previous episode, a regular episode, that one had some failures of the material itself, and so water leaked through the dam. This one overtopped, so it's a bit of a different type of failure. So we're not necessarily repeating the same type of story, but I do find dams to be just fascinating. We've done a number of these already, and they're also interesting. When a low pressure weather system reached western Pennsylvania on May 28th, 1889, so 3 days before the flood, it was the heaviest rainfall event ever recorded in that part of the United States. They got an estimated 150 to 250 millimeters of rain over 24 hours.
There's places in the world that don't get that much rain in a year.
For our American friends, that's 6 to 10 inches of rain in 24 hours. That is an insane amount of rain. I think, Brian, correct me if I'm wrong, because I know we've talked about this. I think when Calgary flooded in 2013, I think we might have just hit 6 inches, maybe. I don't even know if we got that much water. I think they estimated 6, but I think we might have actually only got 4 inches of rain over 24 hours. And we flooded a considerable part of the inner city of downtown, of all the low-lying river basins. 6 to 10 inches, 150 to 250 mils is a lot of rain. And that's in 24 hours. So this is 1889. I think they're still dealing with telegraphs. I don't think we've discovered radio yet, maybe. So communication is tricky. They don't have the weather forecasting data that we have nowadays. So I don't know how much of a heads up they had. Had the dam been maintained properly, this probably wouldn't have been as catastrophic as it was. So Lake Conemaugh was the reservoir that was created by the dam. And after this rainfall, or I guess nearing the end of this rainfall, the water was almost cresting the dam. The residents worked to unclog the spillway, which was blocked by a broken fishing trap and other debris. Another group tried to dig a ditch to divert water out of the reservoir before it could overtop the dam, and more residents tried to pile mud and rock on the face of the dam to save the eroding wall, all while raining intensely. So I'm sure that was a really, really fun exercise for them. They tried, but none of these groups were successful.
And back then, they didn't have the same mechanical ability we have with giant earth-moving equipment and loaders and buckets, and they were probably largely working by hand or with very rudimentary steam shovels to move anything around.
I believe they were trying to do this all by hand, because it's raining. It's early in the morning. So essentially what happened is it's raining, they go to sleep, they wake up in the morning, and they're like, oh crap, this lake is very full. We should try to do something. And so while it's still raining, they're trying to relieve some of that water so that the dam doesn't overtop. But like I said, they weren't successful, and eventually an engineer at the dam sent word to Johnstown twice by telegraph to warn them of the dangerous situation at the dam. But because they sent someone else to do it, and a variety of other reasons that I'm not quite privy to, the message never arrived at Johnstown, and they really had no idea this was coming.
So by 1 p.m., exhausted from trying to protect the dam, the residents retreated to higher ground. At some point, I think you have to recognize that their efforts, or what you're trying to do, is just not going to work against that volume of water and forces of nature. And unfortunately, between 2:50 and 2:55 p.m., the dam finally breaches. So it took about 65 minutes, so just over an hour, to empty 14.55 million cubic meters, or almost 91 million bathtubs, of water in the reservoir once the dam started to fail. There's a lot of water that's behind this dam. There's a lot of water that releases from the dam. And like Nicole said, it impacts so many things downstream. Like we've talked about fires a lot. Fires generally impact one building or maybe two buildings. Dams can impact millions of people downstream and livelihoods.
I think one of the important things too to consider, and it's not something I necessarily think about immediately, but once that dam starts to overtop, the water flowing over the crest of the dam starts to erode the crest. So now that mound of dirt gets smaller and smaller or shorter and shorter as more water flows over the top. And so by the time, 65 minutes have passed, this earthen dam it's pretty much gone at that point because all of the water that's flowed out of that reservoir has eroded the entire dam.
Yeah, once it starts, there's no going back. It's a constantly increasing negative feedback loop, and you can't really stop it once the dam's breached.
Yeah, and I think this is part of why I find these dam failures so interesting is that water is just a extremely dangerous but also just a magnificent element. The force of water is really, really impressive. Dangerous, very dangerous, but also very impressive.
So as the mass of water makes its way down the Coname River, it picks up trees, it picks up houses, tons of other debris, and it reaches a 24-meter high railroad bridge called the Coname Viaduct, and the debris jams against the stone's bridge arch until it collapses within 7 minutes. There's a ton of water, like Nicole said. There's a ton of debris that's now been picked up, all these rocks, all these trees, some houses. Jams it against the viaduct. The viaduct collapses. That joins the flood downstream. And the flood finally reaches Johnstown 57 minutes after the dam collapses. So the water traveled at 64 kilometers per hour, and it reached a height of 18 meters in some places. That's equivalent to a 6-story building and double the speed you can go in a playground zone. Just like some other floods that we've talked about, the water is moving, and the wavefront that it creates, it's really tall. I live on the 12th floor of my condo building, so something half the height that I live at is pretty ridiculous. There's tons of buildings in most cities that aren't 6 stories tall. In Johnstown, the Stone Bridge, a 7-arch railroad bridge, created a temporary dam from the debris carried by the flood. This caused a surge rolling upstream, which, thanks to gravity, returned back to the dam, and a second wave of water hit the city. To make matters even worse, the debris caught by the bridge caught fire and burned for 3 days, which I think is kind of ridiculous. Hey, it's flooding, it's in the water, and there's a whole bunch of debris on fire. This debris pile spanned 121,000 square meters and was 21 meters in height. It took workers 3 months to remove it all, mostly due to a huge amount of barbed wire from the ironworks factory entangled in the wreckage. They eventually used dynamite to clear it.
So we're going to talk a little bit about the damages that occurred because of this flood. And I just want to preface this by saying that these numbers are not good. In fact, they're really horrible. I certainly don't track our episodes by how many people perished in the failure, but I would say this is up there, if not the highest numbers we've seen on one of these episodes yet. If you don't want to hear that, please fast forward. I also want to say that I think the fact that the Johnstown had no idea this was coming is a big, big factor in the number of people that died because they had no warning signs that this was coming. So here we go. An estimated 2,209 people died from this flood. This included 99 entire families, 396 children, 124 women, 198 men. 98 children were orphaned because their parents died in this flood. And I think this is one of the saddest parts. 777 victims were never identified. Human remains believed to be from this flood were found as far away as Cincinnati, Ohio, which is a 6-hour drive west. Holy forking shirt balls, folks. That's a long way from home.
In addition to the people that perished, 1,600 homes were destroyed, $17 million in property damage at the time, so $540 million in 2022 dollars, over $500 million in property damage. 10 square kilometers of downtown Johnston were completely destroyed. Rail service was restored 2 days later by building a temporary trestle bridge in place of the Coname Viaduct. This did allow food, clothing, medicine, and other provisions to arrive, and it definitely aided in the recovery. So the founder and president of the American Red Cross, Clara Barton, arrived 6 days after the flood and stayed for 5 months. At the time, the American Red Cross had only been in operation for about 8 years. At its peak, the army, and this is an army, of relief workers totaled 7,000 people. And Frank Shoma, the last known survivor of this, died in 1997 at 108 years young.
So, as I mentioned at the top, there was a formal investigation, and that was done by the American Society of Civil Engineers, which we have talked about a little bit before. They have listed 7 wonders of the modern world, and we've definitely covered a few of those on our Engineering Marvel episodes that we do every 10th episode. And they oversee, still to this day, civil engineering at least across the United States. And I know they develop a lot of standards and regulations and guidelines that are followed in Canada as well as the US. So they're an integral part of structural design throughout North America. So they appointed a committee 5 days after the flood to investigate the disaster. James B. Francis, who was one of the founding members of the American Society of Civil Engineers and also a hydraulic engineer, led the investigation. As part of the investigation, they visited the dam, reviewed the original engineering design and modifications, interviewed eyewitnesses, commissioned a topographic survey of the dam remnants, and performed hydraulic calculations. For fear of being involved in litigation, and I think this is really interesting, the report was not made public until 2 years after the flood. So they were really nervous about the implications of sharing this report, this investigative report, with the public, and so they hid it for 2 years before they released it, which doesn't happen nowadays. There's obviously lawyers involved nowadays when they publish these types of reports that make sure that they're legally sound to publish, and if they are aiming blame at any one person or any group or a number of groups, that it's backed up with firm data. So the process is a little bit different than it used to be, but I do think it's interesting that they hid this. So the report found that, and this is the initial report from 1889, found that even if the dam had been maintained to the original design specifications with a higher embankment crest and 5 large discharge pipes, that the dam still would have overtopped and led to this flood. However, in 2016, a hydraulic analysis contradicts those results and confirmed that changes made to the dam significantly reduced its ability to withstand major storms, and that lowering the dam crest by about 1 meter and failing to replace the discharge pipes reduced the dam's capacity by half, which is significant. So if you think of the dam, it's not a square box, it's more like a cone. And so the cross-sectional area at the bottom of the dam is much smaller than it is at the surface of the dam. So as you go from the bottom towards the top, the amount of water you can hold per meter of height gets larger and larger because the area of the dam expands as it gets taller. That's why, only a meter shorter than it should have been, but reduce the capacity by half. Also, the discharge pipes were critical because that allows you to relieve some of the pressure so that the dam, it stays really full, but it doesn't overtop. And yes, you may still have a little bit of flooding downstream because you have excessive water going down the river, but it's not so much that it's eroding the dam and releasing the entire reservoir.
So survivors of this blamed the South Fork Club for their modifications to the dam and accused them of failing to maintain the dam properly. However, the lawyers for the club, 2 of whom were members, argued that the flood was a natural disaster and the club was not held legally responsible, and they paid no legal compensation. Even so, several club members contributed thousands to the recovery and rebuilding of Johnstown and surrounding towns affected by the flood, which I think is a good gesture whether you were legally responsible or not for this one. The fact that survivors were unable to recover damages was due to financial structure that kept personal assets separated from the club, and that it was difficult to prove fault from any one particular owner. This was heavily criticized, and in the 1890s, state courts adopted Rylands v. Fletcher, a 1968 English tort law which had largely been ignored previously. This allowed a non-negligent defendant to be held liable for damages caused by unnatural use of land.
So one of the things I love about these failures is I have these preconceptions when I go into research and I think I know what I'm going to find. And I always find surprises. And so I think it's really cool that this flood impacted legislation and legal precedent in the future. And yes, of course, as we said, the victims of this flood were not necessarily compensated, but the outcome of that, while of course not good for them, was able to change precedent moving forward. And so they did eventually make this change and hold defendants liable for damage for unnatural use of the land, which I just think is really interesting and something I wasn't expecting to find. So as I mentioned at the top, Johnstown was also hit with a number of other floods. They got hit in 1894, 1907, 1924, 1936, and 1977. So
This is a place that seems like it floods a lot.
yeah, which is why at the beginning of the episode I said maybe this isn't a great spot to put the town. That's just my thoughts. You do you. After the 1936 flood, the United States Army Corps of Engineers, and we've talked about them on a few different episodes, they look after a lot of large engineering projects that are done by the US government throughout the country. They dredged the Conemaugh River to nearly 20 feet deep and built the river walls out of concrete. But that 1977 storm, they received 275 millimeters of rain in 8 hours on July 19th. That put the city under 2.4 meters of water. At least the dam was never rebuilt. After it was destroyed in 1889, they never rebuilt it. And so there wasn't a dam failure or a wave of water that they had to deal with. They just had to deal with the regular river flow and the river rising. So while it did flood in 1977, it was nowhere near as catastrophic as the Great Flood of 1889.
So there you have it, the Johnstown Flood, or the Great Flood of 1889. The poorly maintained South Fork Dam, with a reduced capacity and no overflow capability, was ill prepared for extensive rainfall, and the towns downstream bore the brunt of those shortcomings.
Thanks for listening to this mini failure episode. For our regular episodes, check out Failurology wherever you get your podcasts. If you want to chat with us, our Twitter handle is @Failurology. You can email us at thefailurologypodcast@gmail.com. You can connect with us on LinkedIn, or you can message us right in the Patreon app. And there's links to all of these in the show notes. Bye, everyone. Talk soon.